Guys, I hope you're doing well. So here we have our addition and subtraction circuit. So I'm just going to go through all the specifications of the circuit. So first of all, let's start with the input. So I have input A, which is my first operand. Then I have input B, which is my second operand. And then lastly, I have the third input, which is the mode. So the mode basically specifies whether this is an addition or a subtraction operation. So when the mode is set to 0, it indicates that this is an addition operation. And when the mode is set to 1, it basically indicates that this is a subtraction operation. So let me just try to illustrate with an example. So right here at input A, we have 1, 0, 0, 1, which is 9. Then here we have 0, 1, 0, 0, which is 4. So since the mode is set to 0, that means we have an addition operation. So 9 plus 4 should give me 13. So let's run it. And as you can see at our output, we have 1101, which is 13. Okay. And also notice that our our um our, our output carry is going to be equal to 0 in this case. So now let's switch the mode to 1. So if I switch the mode to 1, now it becomes a subtraction operation. So that means now I'm going to have 9 minus 4. So if I do this, and as you can see, now I have 0, 1, 0, 1, which is 5, because 9 minus 4 equals to 5. Okay, so for subtraction, we don't um, consider the carry output. We don't consider it. Okay, we only consider the carry output when we're dealing with addition. All right, so let me try maybe another example. So maybe let me try. So this is going to be what? This is going to be 13. Oh yeah, like what like we previously had. It is going to be 0, 1, 1, 0, which is 6. So 13 plus 6 should give me what? 19, right? So let's run it. So again, since our mode is set to 0, this means that this is an addition operation. And since this is addition, we have to consider the carry output. So in this case, I'm going to have 1, 0, 0, 1, 1, which is 19. So if I switch the mode to 1, that means I'm going to have a subtraction operation. So I'm going to have 19, I'm going to have 13 minus 6. So what is 13 minus 6? 7, right? So again, since this is a subtraction operation, we do not consider the carry output. We only look at our output. So 13 minus 6 is going to give us 7, which is 0, 1, 1, 1. Okay, so that's basically how the circuit works. So now I'm just going to explain the components and their purpose. Okay, so I'm going to start with the mux or the multiplexer. So this is actually like a 2-to-1 multiplexer. So what it basically does is it's basically going to choose between input B and its ones complement based on the mode selected, or like on the value of the mode. So when the mode is 0, it basically selects B, and when the mode is 1, it basically selects the ones complement. Okay, so as we all know, the subtraction um, and addition are kind of like similar. Let me explain. So we know that if you have A minus B, is basically the same thing as um, the sum of A and the two's complement of what? Of B. And so we know how to find the two's complement of B, right? So how do we do that? Or the two's complement of any number rather. So to find the two's complement of any number, you first need to um, get the ones complement, and then you add 1. Okay. So that means if we have a subtraction operation, that means the ones complement of B is going to be selected, right? Then once it's selected, also notice that the mode is also connected to the carry input of the adder. So this basically now adds 1 to the 1's complement of B, thus giving us the 2's complement of B. Okay, so that's how we get the subtraction component. So when it's addition, nothing much really happens, because if you set the mode to 0, that basically means that we have no carry input. That's the first thing. We also simply select B, and we just compute the sum of A and B, to get our answer. So that is basically how this circuit works. So if you guys have any thoughts or any inputs that you might want to share, please feel free to write that down in the comments. And if you have any questions, I'll be willing to answer and even help you out with, you know, any other problem maybe that you might encounter in other IC design related problems. So thank you guys for listening. Peace out.